next presentation is going to focus on the intersection of assistive technology and robotics. And this team was challenged to create a prosthetic that was able to fit a patient's leg for a longer period of time so that they would, even after they grow, even after a child grows a lot, they can still use the same prosthetic. So the next group can go ahead.
Hi, my name's Romina.
My name's Pranav.
My name is Ritvik.
And we created an athletic patient prosthetic, which we call app. So unfortunately, some people are either born without limbs or need to have them amputated due to disease, accidents, etc. The solution to this is prosthetics, or fake limbs that serve almost as a replacement to the lost limb. With the most common prosthetic needed being a leg prosthetic, these are often very expensive, heavy, and sometimes do not act like a real limb would. One very common problem with prosthetics, especially for younger patients, is that they are constantly growing. This means that the prosthetic has to be changed as they grow, resulting in the need to invest more.
While we were brainstorming, we conducted some background research and learned many things. We must take into account what the patient would like, such as comfort levels, durability, and how to attach the prosthetic. The materials that are needed to create the prosthetic can be 3D printed plastic or metal, and we also learned that we could use CAD and a 3D scanner to create precise images of the patient's leg and perfectly design a socket to fit it. The prosthetic is controlled by using electrodes that can read messages that the brain sends through nerves.
We propose a solution that is durable, easily accessible, and comfortable to the patient. Because of these qualities, it is ideal for fitness. We will include several materials that will support these qualities as well as making the features of the prosthetic in range of the ability of the patient. Some features of the prosthetic are height adjustment, comfortable insides, knee joints, extra long durability, and expandable rings. Thanks for listening. Oh, and that's our CAD.
Okay, thank you so much for that presentation. There will also be another group that's going to be presenting how they tackled this challenge in the robotics and engineering track.
So this is our above knee prosthetic limb presentation. I'm Sefad.
I'm Tahana.
And I'm Sahithi.
Unfortunately, some people are born without a certain limb, so they need to get a prosthetic one made for them, so that they can do everyday activities. We have to create a design of a fake leg so that these people can also do things that everyone else does. The leg has to be easy to manage, light, and affordable. Also, the prosthetic limb doesn't grow with the body, so it will appear to get smaller, but the person is actually only getting bigger. This is also one of the problems we have to fix.
So our group was very decided on the materials we had to use in our prototype. Some of us thought plastic would be a better material because it was cheaper, but some of us thought we should go with metal because it had a good amount of durability. The main factor was the material had to be light and user-friendly. We ended up settling on lithium as a metal because it's very durable and very light, and it can float in water. For the mechanism, we were also split on using a specific motor or a rubber band. Some sort of mechanism, I guess. To be cost effective, we ended up using a rubber band type of mechanism because it's very cost effective and easy to manage. And the biggest feature of our product was a modular design, so it's very adjustable for all sizes.
Solution. Our solution is an adjustable prosthetic leg. It will be made of lithium since lithium is very light and will make someone feel as if the leg is actually there. Our foot is different since it can adjust to the person. Our foot will be attached to the body with something that is made of stretchy materials like fabric or rubber. It will then be coated in fabric that matches the skin color so that it looks like an actual leg. How it works. Our prosthetic limb works like any other one. It helps you do basic tasks like sit, stand, kneel, and walk. This is done the way a normal leg would do. When you sit down, the rest of your body will drag the prosthetic into position. On top of this, our prosthetic limb can adjust to the size of the user. This is especially useful for growing children who grow very quickly. When you put this on your foot, there will be a band-like structure that you can attach to your leg. This structure is stretchy and will stretch with the person, so that as long as it grows, the leg will grow with them.
The impact. The impact on the people who are using the fake limb will hopefully be a good one. They'll find it easier to do certain activities. Our design will also benefit other people because it will make it easier for them to take care of the people who need to use the prosthetic limb. This is our CAD model for the limb. The colored leg is the prosthetic one, and the white one is the real leg.
We're going to move on.